statistics, specifically frequency distributions and graphs. All right, in this first video on statistics, our objective is to organize and present data. And we're going to look at three ways to do this: frequency distributions, grouped frequency distributions, and stem and leaf plots. All right, so moving on with it, we're simply going to define what they are, and then we'll take a look at an example as to how to create one. A frequency distribution is a two-column presentation of data in which the data values are listed in one column and the frequency, or the number of times each value occurs, is listed in the adjacent column. Okay, let's take a look at an example of how to create a frequency distribution. So, construct a frequency distribution for the data showing final course grades for 20 pre-calculus students. And here they are. Hope I have 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. Yes, I do. Grades from A to F. Okay. Again, you look at the definition. Our first column consists of the data values, or the data values. And so our first column consists of the grade, in which case we have A's, B's, C's, D's, and F's. And again, the first column is our data values. And the adjacent column, or the second column, is how often each of these data values occurs. So if we look here, the letter A, we have 1, 2, 3, and there are only 3 A's, so the frequency is 3. There are 5 B's out of these 20, 9 C's, 2 D's, and 1 F. And it's important to note that we have 20 here, and that when I add up the frequencies here, I want to check this. 3 plus 5 is 8, 8 plus 9 is 17, plus 2 is 19, plus 1 is 20. The sum should be 20 to make sure that I've included all of the data values. All right, so now what happens if we have a whole lot more, or a much greater number of data values? So if there are many data values, this frequency distribution can get a bit cumbersome. Okay, so we're going to move to, in these cases, we're going to move to a grouped frequency distribution. Okay, very similar idea. It's still a two-column presentation of the data, but in this case, the data values are arranged into equal width groups, or classes, in one column, and the frequency, as before, is still listed in the adjacent column, the second column. But the first column has changed. The first column is now going to consist of classes, equal width groups, so that we don't have to list 18, 19, 20 possibilities in our first column. Let's take a look at an example of that. Okay, construct a grouped frequency distribution for the following 37 exam scores. I have 37 exam scores here, and you can imagine I have a couple that repeat. I would imagine, here's a 71 and a 71, so that one occurs twice. Here's a 77 that occurs twice. But if I were just to do a frequency distribution, I'd have quite a long list of those numbers, and that would get a bit cumbersome. So we're going to group the data into classes, okay? And you wanted a couple things to keep in mind. You, of course, need to note the lowest and the highest values. In this case, the lowest value is 41, it's here, and the highest value is 99, and it's right here, because they have to be included. So you need to make sure you know the highest and lowest values. And in general, you're looking for 5 to 8 equal width groups or classes. It doesn't do anybody a whole lot of good if you have one group. You know, the scores from 40 to 100 and they all fall in that range. Doesn't really help anybody. And it doesn't do a whole lot of good if you have 10, 12 of these, because they get to be a bit too many. So you're looking for between 5 and 8, and you know, inclusive, 5 to 8 equal width groups. In this case, my classes are of size 10, of class width 10. Okay, so between 40 and 49, I'm grouping between 40 and 49, 50 and 59, 60 and 69, and so on, up to 90 to 99. And between 40 and 49, I have 1, and the 41 is right here. Between 50 and 59, I have 5. Let's see, 58 is 1, 52 is 2, 58 is 3, 50 is 4, and 57 is 5, and so on and so forth. There are 4 between 60 and 69, 15, a whole lot of these between 70 and 79, 5 between 80 and 89, and 7 between 90 and 99. And again, you'll notice you're going to want to total up those frequencies to make sure that you indeed captured every value. We knew there were, we were told there were 37. So we want to make sure we add up these numbers. Let's see here. 6 plus 4 is 10, plus 15 is 25, 30, 37, to make sure we indeed have them all. Okay, a couple things to point out. You'll notice in the first column in the classes, this is a lower class limit. And this number is the upper class limit. And the way you find the way you find a class width, so the class width is equal to an upper minus an upper, or a lower minus a lower. Because it looks like, 99 minus 90. This is a class width of 9. That's not true, because you're not including the first value 90 here when you subtract. So we're going to look, for example, of upper minus upper. Well, we'll look at, let's say, for example, 99 minus 89. And that gives you a 10. 99 minus 89 gives you a class width of 10. Or a lower minus a lower. How about 50 minus 40? Those are two lowers, and that's also a 10. So your class width can be a little misleading if you just look at the class. You have to subtract an upper minus an upper, or a lower minus a lower to get a class width. Okay, the last one to look at would be stem and leaf plots. Okay, if I can get my paper centered. All right, a stem and leaf plot is, this is a newer, a little newer. I mean, it's probably within the last 30 or 40 years, would be my guess. Frequency tables have been around for quite some time. Stem and leaf plots not nearly as long. This is a table where each data value is split into a stem. The stem is either the first digit or the first digits, depending upon how many digits are in the number, are in the data value. And a leaf is split into a stem and a leaf, which is usually the last digit. The leaf is usually just the final digit, whatever it is. The pro, or the positive to stem and leaf plots, is they show the popular classes as well as the exact data values. So if we go back to here with our grouped frequency distribution, we can see that the 70 to 79 class is the most popular class. It has 15 values in it, but we don't know what those values are. We just know that's the most popular class. A stem and leaf plot will do both. It'll show us that the 70s is the most popular class, it'll also show us all the values that are within that class of 70s. Okay, so a stem and leaf plot. We're going to use the same data set that we used in the previous example. These are our 37 exam scores. I've just copied them again here. Okay, as usual, because we have to make sure we note the highest and the lowest values. As we remember from just the previous example, 41 is the lowest value and 99 is the highest value. Okay, this is 2-digit data, and so the stem will consist of the tens digit and the leaf will consist of the units digit. So here we're going to plot the stem and leaf plot for 37 exam scores, and here is the stem. The stems are 4, 5, 6, 7, 8, and 9, 40s, 50s, 60s, 70s, 80s, and 90s. And the leaves, they don't need to be in any particular order. You just need to have them go off to the right as you do them. So we look at the leaves for the stem of 4, which scores are in the 40s, and we only have the 1. We only have 41. So the stem of 4, which represents 40, only has the one leaf of 1, so 41 is the only value in the 40s. In the 50s, okay, 58 is the first one. Oops, we need my data set. Sorry about that. Okay, in the 50s, my first one, 58, so 8 is my first leaf. Moving across to capture all my 50s, 52 is my second leaf. Moving across, another 58. Moving across, and I'm just going left to right, 50 and then 57. So there are the leaves that correspond to the stem of 5, and this tells us 58, 52, 58, 50, and 57. Okay, each leaf is one data value and it goes with the particular stem. Let's look at our 60s. 68. And it does help to, you want to have your columns be neat so that your numbers fall your numbers fall vertically, neatly. 68 is my first one. Let's see here. 62. Okay, under the 2 is a 62. 69. And is there any more? Yes, 69. So I have 4 leaves that go with the stem of 6, representing 68, 62, 69, and 69. 70, and we know we have 15 of those, I believe, from our previous example. Let's see if we can find 73, 75, 79, 79. So those are 4 in the first row. 77, 75, 77, 75, 75, 73, 73. So 5, 3, 3, 7, 1. Okay, 7, 1. And then 7, 1, 5. And I think we knew 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I may be missing one. 3, 5, 9, 9, 7, 5, 5. I'm missing a 76. Oh yes, I'm missing the 6 right here. I neglected that 6. So let's put that 6 in. Yep, made a mistake here. I forgot this 76. So 6, 7, 1. And then 7, 1, 5. There we go. Got them all. As I knew from the grouped frequency distribution, I should have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got them. Okay, 80s. 87, 83, 89, 89. 87, 83, 89, 89, and then 81, and then that's it. Okay, in the 90s, let's see, 94 and 96, so there's a 4 and there's a 6. 99 and 97, so there's a 9 and there's a 7. 95 is the only one in the third row. Okay, fourth row, I have 98. And then the fifth row, I have 90. Okay, so there's a stem and leaf plot for those 37 scores. And if we were to count up all the leaves, each leaf represents a data value. We would need to have 37 of these because we know we're talking about 37 exam scores. But you can see in the stem and leaf plot that not only are the 70s the most popular, you can see by the length of the leaf, because I did the columns, I put numbers in columns neatly. I can see by the length of the leaf that 70s are most popular and 90s are the second most popular, but I can also see the individual values, which I can't see with the grouped frequency distribution. So there you go. Take a look at frequency distributions, grouped frequency distributions, and stem and leaf plots.